Number 11 on worksheet 3. Find the volume of the solid generated by revolving this region about the line x equals 9. First quadrant, so if I'm graphing, I don't have to worry about that. All the way out to x equals 9. Y equals 0, x equals 9, x equals 0, and then 1 plus square root of x. So that thing is maybe a little bit weird, but I can plug in some key values here. If I plug in 0, I get 1. If I plug in 4, that'd be my next one I'd want to plug in. I'd get 3. 4 would be about right there. And if I plug in 9, that's convenient because that's where we're going to, I would get 4. So it's the square root graph that's been bumped up 1. And that's our region that we're going to do something with. Okay, now that's my picture. Revolve that around the line x equals 9. So x equals 9 is my axis of rotation. So I like to visualize this or draw it, so I'm going to copy it over, like reflect it over. So it'll take me out to 18. And it's not a bad one to reflect. And then there's some circles in there. Oh, now I see why this is a good one. So, template. Maybe it's good to start with the template. dy or dx?
dy.
dy.
Are you asking us one? Or are you just stating that it's dy?
And overall, I need to go from 0 to 4. But there's kind of a trick in this one. Well, let's back up a second. Is this discs or washers? Is there a hole in the middle?
Disc.
Yeah. Wait.
It's a
Which
disc.
one? It's a disc. There's not a hole in the middle. It's solid all the way through. So that's a disc. It's a disc. So I don't have a little r. There's only a big R from the center or from the axis to the outer edge. The trick to this one, though, is, you see what the trick is going to be for this one?
No.
What's big R down here at the bottom? 9. So it's the big R is 9 until you get to 1, which means I need to split this up and go 0 to 1 and then 1 to 4, because they have different big R's. So from 0 to 1, big R is 9. So that's an easy integration. I mean, it's in the calculator anyway. That's just going to be pi r squared h. So that's the volume of a cylinder. That bottom cylinder. When we start to get to 1, though, or we start with 1 and go to 4, that r is a different deal here. Okay, so that big R, it's left and right, so I want to do the right minus the left. So what's the rightmost spot? 9. And the leftmost spot is on this line, or on this curve, I should say. And that curve is y equals 1 plus square root of x. Except I need it in terms of y. So I'm going to move. I got to solve for x. So I'll move the 1 over, and then square root both sides, or excuse me, square both sides. Y minus 1 squared. So that r distance is 9 minus y minus 1 squared. You can check that, because what should the r equal when y is 1? That should be 9. So when y is 1, r should be 9. Yeah, I can see that. That works. And when y is 4, what should r be up here at the top? What's the radius of that thing at the top? The very top. 0. I plug in 4. 4 minus 1 is 3. 3 squared is 9. 9 minus 9, 0. So I feel pretty good about that because I checked it. The bottom r should be 9. The top r should be 0. So 0 to 1, pi times 81 dy plus 1 to 4, pi times r squared dy. That one is one that could be on the test. Like, that's representative of the maximum difficulty we would want. So you do have to divide it into 2, but the 2 pieces are, one of them is just a cylinder, but the other one is, moderately difficult. The calculator thing on this one would be kind of a pain. Math. Oh, I don't want that calculator. Math 9, 0 to 1, pi times 81. Well, we'll go with y, although we could get by without that. So that's the bottom cylinder.
Yeah.
If you wanted to not jam all this together in one, you could store that and then come back to it. And that way you're not trying to type in too much at once. So now I'm just going to do the second piece, 1 to 4. I'm going to put the pi out front. Open parentheses, 9 minus parentheses, y minus 1 squared, close parentheses, squared, dy. I think that's right. Plus area, the other area, 661.619. It's on there, so I feel good about that answer. That's a tricky one we haven't seen yet, where you have to divide it into 2 pieces, because the big R was different for the top piece and the bottom piece. So that was should have started and only done that one. That's right. Let's look at worksheet 4. Do a couple of these, because this goes back to area and volume by cross-section. So this will start our review. Right, the review is area, or here's the 3 topics: volume by cross-section and volume by revolution. That's the three main topics. So number 3. Sorry. Area. So that's top minus bottom dx, or right minus left dy, depending on your top minus bottom dx, or right minus left dy. Cross-sectional area is add up all the areas, dx or dy, depending. And then by revolution, that's the pi big R squared minus pi little r squared times dx or dy, depending. Yeah, it's like, how hard can this test be? There's only 3 formulas, right? Some of you guys are writing that down. That's, yeah, I mean, I don't want to say that's it, because within there, that you got to know how to integrate all the different things. You got to know how the calculator works. You got to know how to find big R and little r, find the limits, think about dx, dy. There's a lot going on. Are we good with that? Can I fast forward to number 3? All right, k is between 0 and pi over 2. The area under the curve, y equals cosine x, from x equals k to x equals pi over 2 is 0.1. Then k equals, okay, so the cosine graph, let's see, back all the way up here. Cosine graph looks like that, right, from 0 to 2 pi. So from 0 to pi over 2, it looks like that. There's our cosine graph. And there's some x equal k in there, where the area from k to pi over 2 is 0.1. So I don't know where k is, but I do know that this area equals 0.1. Okay, I think I've got the picture right based on what it told me. Under the curve, cosine of x from k to pi over 2 is 0.1. Well, area under the curve, that's integral, equals 0.1. So I know the answer. Integral from what to what?
K to pi over 2.
K to pi over 2, which means this is not going to be a calculator problem, because I got to figure out what k is. Oh, unless I plug in all of those and see which one gives me 0.1.
Yeah.
Nothing wrong with that. And the area, the heights that we're adding up, are cosine of x dx. So yeah, the calculator way would be to plug in each of those answers and see which one gives you 0.1. Which wouldn't be bad, because once you typed it in once, you can go up and use the entry you just got and change k until you get the right answer. But let's do this sort of the real way here. Well, we got a calculator. That's probably the way I would do it. So I'm just going to play guess and check and see which of those k values work. So Math 9, 1.471 to pi over 2 cosine of x dx. So this really isn't that hard to check with my different k's. So that area is 0.005, so that's not it. All right, and you guys know that second entry will copy down the last entry. And so then all I have to do is go change that lower limit, 1.414. So this really isn't that hard to guess and check. 0.012, so that's not it either.
It's close.
Second entry, 1.277.
I think that's the closest we can.
0.04. I'm trying to get to 0.1 though, not 0.01.
D. I thought you were on D.
Yeah, you're right. There's going to be a rounding thing, so it's probably not going to land on exactly 0.1.
And then typing in D gets you 0.099899557.
Yeah, I'd say that's pretty darn close to 0.1. So kind of a guess and check there. But even still, you had to be able to read and interpret that problem, set up an integral, and then guess and check. So that was day one. We're going to do one from each set, basically. That was area under a curve, and a tricky one. Number 4, let R be the region in the first quadrant bounded by the graph of y equals x cubed and the line x equals 2. Okay, so x cubed is going to go up to 8 if we're going to 1, 1, 2, 8. So there's my region. First quadrant, y equals x cubed, line of x equals 2. And the x-axis, so just that triangular looking thing. That's the base of a solid whose cross sections perpendicular to the x-axis are equilateral triangles. The area of an equilateral triangle, that's the yucky one, that
Square root 3 over 4 sine squared?
Square root 3 over 4 s squared. So I have equilateral triangles coming up out of the page, making this solid. So I'm going to add up all my triangles. The slices are dx, which means I need x limits, so 0 to 2. 2, root 3 over 4, and then I need some expression for s. That s is that height, y, and that height is x cubed. Top minus bottom, x cubed minus 0. So I feel like that one wasn't terrible. Oh, look at my answer choices. I'm almost positive I can rule out. Which one would you rule out first before you even do anything?
The pi.
The pi. That's if somebody rotated something or maybe did some circles, semicircles. I'm guessing it's A or B because of the square root 3. I don't see how else that square root of 3 would go away. Math 9, 0 to 2. I could hold the square root of 3 off.
Yes.
Yes?
Yes.
And then stick it back on and then see if it matches that better.
Mm-hmm.
So I'll hold off the square root of 3 then. And I can do x to the 6th, save myself a little bit of time by doing a little bit of math in my head. I'm thinking the 7 now, right? Because the antiderivative of x to the 6 is going to be x to the 7 over 7.
Mm-hmm.
So I'm betting on B here. 32 divided by 7, is that the same thing? Yep. So answer choice B. And probably could have got it down to a 1 out of 2 chance just once you wrote down, or once you recognized that it was an equilateral triangle. Which would be nice. If you can get every problem down to 1 out of 2 on the AP test, you'll make a 3. Maybe a 4 if you actually know some of them. All right, so that was the cross-sectional area. Let's do number 6. A revolved problem. So basically we'll work 3 problems off the review, 1 from each type. Area, cross-sections, revolutions. Let S be the region enclosed by the graph. Y equals 3. Okay. So 0 to 1. going to revolve around y equals 3. So y equals 2x, that would just be the line with a slope of 2. This would be a no calculator question probably because of the way it's set up. 2x squared, well, that's just going to be a parabola. It's a little steeper than normal, but it would start at 0, 0. If I plugged in 1, I would get 2. So there's my base region. And I want to revolve that around y equals 3. All right, I need to slow down. Okay, caught up to me? Okay, volume is integral pi r squared minus pi little r squared d something. All right, if I rotate this around y equals 3, which way are what are my slices? Are we slicing x or y? X slices. I don't know if it helps to draw it or not. Slicing in x. So that means my limits are in x. So 0 to 1. And then I need to figure out big R and little r. So big R from the axis to the outer edge. So top minus bottom. So the top is 3, and the bottom is, well, that picture is not great. R goes to the 2x squared. So, I'm starting to look at my answer choices here. They're all 0 to 1. They also all have the pi out front. So big R is 3 minus 2x squared squared. The squared thing is what throws some people off. Some of you made that mistake yesterday. Like you wrote it down, you wrote this down right, and then if R had a squared in it, you forgot to square the R because the R was already squared. So just be careful. And then little r, by the way, as I'm looking at my answer choices, A looks like a clear winner here, but we better make sure. Little r is from the axis to the inside edge. So that's 3 minus 2x. Little r is 3 minus 2x squared dx. And that is still answer choice A, I think. Yeah. Let's see. Big R, little r. So answer choice B got big R and little r confused.
Which would catch some people out.
And I'm not sure what C and D those people are doing. I don't know. Oh, they're squaring. Oh, if they say one of those is R and they just square that. That's where those would come from, but those people have left off the 3 or forgot about the 3. All right, it's still a ways until test day. How are you feeling in regards to topics 1, 2, and 3? If you want to phrase them that way. Area, volume by cross sections, volume by revolution. Any of those better or worse than the others?
Still think that number 3 is fine.
Is number 3 still the hardest? Pardon?
I feel like the thing yesterday really helped. So I
Good.
chose that one.
Number 2 is
What about number 2, Nick?
I don't know, it's like the
Yeah.
Is what? Is the easiest or the hardest?
like weirdest.
The weirdest one? Number 2 is the weirdest one? Is number 1 universally the easiest one?
Yeah.
Okay. So then on 2 versus 3, who thinks 2 is the harder one, the cross sections? Show of hands. Who thinks 2 is harder?
I only think the part of 2 that's harder is having to memorize all these like.
Okay. Having to memorize the weird formulas.
Maybe
Who thinks 3 is hardest? Anybody think 3 is harder?
depending
Okay.
on the complexity.
Not a clear contender. We need to keep working on both.
It's hard. It's easy number 3 than 3. Just make us try to solve one of them.
That's what I'm looking to do.
See if we can figure it
Why don't we try 58? So we have 13 minutes left. And a free response question is supposed to take 15 minutes. So turn to number 11. And it basically has one of each.
Oh, no calculator.
Number 11. No calculator, so I would say for now, just to get through it, set them up. I would not evaluate the integrals yet. In fact, the very last one says don't evaluate because you don't have a calculator. So see if you can do number 11. Because 11a is an area. That should be straightforward. 11b is cross sections. And c is a revolution. So try number 11. A little taste of everything. Minus g, is that the question?
I guess.
So g is the one with a cosine in it.
What'd you do?
So that's got to be this one.
Yeah.
H is an upside down parabola, so that's got to be that one. Wait, did I label those wrong? G is the cosine,
Yeah.
so that's g.
What'd you do?
So it's h minus g. You were right to question me.
We're
Wait, isn't
teenagers.
it-
We question everything.
So it's h minus g.
How do we
I labeled them wrong. G is the cosine, so cosine is going to be the one that's kind of wavy.
Isn't it minus 2?
So it's top minus bottom. So it's got to be h minus g. Right, the height of any one of these lines is the top minus the bottom. And then it'd be kind of a pain to evaluate, but I'm not worried about that right now. Part B, cross-sectional areas. So I want to add up all the areas from 0 to 2. And this one's kind of weird because
You could leave it like that.
you could just about leave it like that because it just tells you, it gives you the area of the formula. You don't have to memorize it. It's just 0 to 2, 1 over x plus 3 dx.
So could you leave
And
it
you-
as the first part because that would be calculated already?
Yeah, they'd probably give you 1 point for that, at least one, maybe probably just 1 on this one. What is this integral going to be? Do you know? Because on the real one, you're supposed to evaluate this one.
My brain's already done over.
I don't know if this makes it better or worse. It's the same thing as that. Uh-oh, it's been too long since we've actually done an integral like that, or an integral by hand, maybe.
It's 1. Right?
Why couldn't you just do U substitution?
You could do U substitution.
But it still turned out to be 1.
Oh, you're obviously
What's the integral of 1 over u? Hopefully we know that one.
LNU.
Natural log. So this is natural log of x plus 3 from 0 to 2. So natural log of 5 minus natural log of 3. Finish that one out.
Natural log 5 over 3.
Which would be the natural log of 5/3. I would not go that far. I would safe stop at what you've got right there. But you're right, it would be natural log of 5/3. Right, but do not evaluate when we rotate around y equals 6. 1, 2, 3, 4, 5, 6. So that's an outer r minus inner r. 0 to 2. Big R squared minus little r squared. Dx. Big R is 6 minus the top one. No, big R would be to the bottom one. Little r would be to the top one. Inside radius versus the outside radius. And I think that would count.
Yeah.
Because everything
Labeled.
is already labeled.
And you just
So
plug it in.
you'd be ready to plug it in. And it didn't say plug it in, it said write it, but don't evaluate.
Logan.
Logan, what are you doing?
Nothing.